Hi, Penny. Okay, we are going to attempt to demonstrate the making waves lab. And so the hypothesis is, how does amplitude affect wave speed? So they should come up with a thought on whether they think a higher amplitude will affect the wave speed or not, and write that down on the thing. Then each group will have a slinky, and it says to lay the slinky out so that the turns are a few centimeters apart. We did ours, so it measured, the length of the slinky measured about 1.1 meters. It will probably be better in class if they can do it farther than that, like maybe 1.5 meters will make it easier for them to make measurements. So when we say the turns being centimeters apart, the turns are every coil of the slinky. So the space in between. So once they have that measured off, they'll need masking tape to mark the ends so they can hold it still while they do the lab. And then they're going to turn the meter stick the other way so they can measure the amplitudes. I'm going to send you an updated lab because we found that the 20 centimeters is kind of the smallest amplitude you want to make. So Leah's going to demonstrate the wave that's described, pulling it sideways 20 centimeters and back, and making one wave. Okay, so that wave is a transverse wave. Hopefully they all know the answer to that question. And then I'll send you the answer key with the label drawing on it so you can see that. And so they're supposed to practice making the pulse so it's the same amplitude so they can just be accurate as they do it. And then they're going to make a compression wave, which is also called a longitudinal wave. So I'm going to demonstrate it from this end because I think you can see it better than on Leah's side of it. So you just collect some of the slinky, and the wavelength will be the measure of the rings that you have compressed here. So this is about 1 centimeter's wavelength. And then I just let it go, which wasn't very good, so I'll do it again. You just let it go, and you can see the wave travel up and down the slinky. The next wave... Okay, oh, sorry, I skipped ahead on the compression waves. Backing up to where they have to fill out this chart. They're going to make 3 different waves with different amplitudes. So the amplitude is how far you pull the slinky before you let it go to make the wave. So this is about 20 centimeters, and then 40 centimeters is measured that way. And then, so we did 20, 40, and 60 for ours. They're measuring the time that the pulse travels from one end to the other. So that means from my end to Leah's end, not from my end back to my end. Okay, so that's why it's better if the slinky is about 1.5 meters, because it gives you a little more accuracy with the time and stuff to measure it. So they do 3 waves at 20 centimeters. Do you want to do it going that way because it shows up better? So do one that's 20 centimeters. And so I'm sorry, do it one more time. And so I would mark, so you need timer at time, and then do it again. Time, okay? And then she's going to make a larger wave, and again, so still tell me when to go, and then I'll take the timer and time, and then they repeat each amplitude 3 times. And I'll use the average time to calculate the speed. Then we're back to the compression wave, so same thing. They're going to time how long it takes this compression to get to her end. So I'll say go, and she'll time it down there. Okay, so the next wave that we make is a standing wave, and there's a picture in the lab of different types of standing waves that they can make. So we're just going to make the simplest one right now, which is going to have 1 hump in it. Go ahead there. So you can see, hopefully, that it just has one wavelength the whole time. So when asked to measure the wavelength of this slinky with one hump in it, it's just going to be the measure of the entire slinky, so the 1.5 meters that they measured. Then when we make a standing wave that has 2 humps in it, the wavelength is half the length of the slinky because we've cut the wavelength in half. So the same thing if we make a standing wave with 3 humps in it. The wavelength is 1/3 of our measured value. So so it'd be 0.5 meter if they did 1.5 meters as the original slinky length. So that's the wavelength that we can measure on those standing waves. And so that's the second chart we're using with the standing waves. So they can start with the original one, so the 1.5 meters. And so this time they want to make the wave, and they want to time about 5 seconds and count how many times their hand moves in that time to make the wave. That's how many waves you'll make. Then they can make any of the other standing waves. So if they make the standing wave that has 2 humps in it, they would, every time they move their hand, they would count it as 2 waves that they're making. And the same with 3. Every time they move their hand to make the wave, then they would count 3. And so they count how many waves they made in 5 seconds. So we'll do an example for this. Leah will do, you want to do 1, 2, or 3 humps?
2.
So she's going to make it with 2 humps, and then she will count how many humps she makes in 5 seconds.
That's the 2, 4, 6.
Yeah. So we kind of get it going, and then I'll say, okay, count. 1, 2, 3, 4, 5, stop. And so she counted 22 waves that she made in that process. She counted by 2s, so she counted 22 waves in that 5 seconds. So 22 waves divided by 5 seconds would give you the frequency of 4.4 hertz. And that will go on the second chart. And then they can calculate the speed. The formula is right on there. It's wavelength times frequency. And so they have the wavelength, they counted the number waves per second, and so they'll just multiply those 2 things to get the speed. The last part are questions that they're going to answer in their conclusion paragraph. And hopefully they find that the speed of the pulse did not depend on the amplitude, and they should have gotten pretty close to the same speed on each of their waves, no matter how high the amplitude was that they started. The longitudinal waves, hopefully the speed compared the same to the transverse wave, because the speed of a wave only depends on the medium through which it's traveling, and we only used a slinky to make the waves. And then hopefully they can discuss the difference between longitudinal waves and the standing waves and the compression waves, or the transverse waves. And yeah, so that's the conclusion. So I'll send you the lab answer key with some sample data in it, and let me know if you have any questions after you looked at this video. And we'll do the next one for you in a minute. Bye!